Rightio, quickly running through the solutions for the Term 1 Week 1 quiz for 11 maths methods. Nice easy one to start off, wasn't it? Find the perimeter of the rectangle. It's a rectangle, so we know opposite sides are equal, so I can add in the x plus 4 and the x plus 2. Pick a starting point and go around the object. I know there are rules for perimeter of a rectangle, but picking one vertex to start at and just travelling around until you finish will work for every shape. So it's probably the easiest way to do it. Once you've done that, you're obviously just going to collect like terms. I've got 4 x's there. 4 plus 2 plus 4 plus 2 is 12. 4x plus 12. We're looking for that as an answer, and it doesn't appear there. That's alright. They have got some factorised answers. Well, we can factorise our answer here pretty easily, can't we? And we get 4 outside of x plus 3. So our answer is C. On to the next question. Factorise again. Just looking for the highest common factor between 6a squared and 9a. Out of the numbers it's 3, and each of them both have at least one a, so a is also a common factor. Remaining factors go inside the bracket. So 3 times 2 would have given me 6, but I also need a squared. I've only got one a out the front, so I need another a there. Now when I expand that, I will get 6a squared. To get 9a, the factor of 3 and an a have gone out the front. There's a factor of 3 left over. So 3a outside of 2a plus 3. Looking for answer A. Which is the correct factorisation of this quadratic expression? Your favourite rule in maths is the difference of 2 squares. If you need to remind yourself, you can write it as that difference first. So I'm going to get x plus 4, x minus 4. Note that if I had written it as x minus 4, x plus 4, you'd still have the correct answer. They decided to do it the way I always do it, which is with a positive first. X plus 4, x minus 4. If you expand that, you'll see that it definitely equals x squared takes 16. Factorise this expression, basic quadratic factorisation. We are looking for numbers which multiply to equal negative 6. Some of you will write this down as the product equals negative 6. And add the sum equals negative 5. Mostly you'll be doing that working in your head, but I automatically know there's an x and an x. Sorry, I should actually say numbers that multiply to negative 6, negative 6 times 1, and add to negative 5, negative 5 plus 1. So they are the numbers, sorry, negative 6 plus 1. Why did I change that? So they're the numbers that go inside my bracket. X minus 6, x plus 1. X minus 6 times x plus 1. Checking if you expand it, you get x squared minus 6x plus x will be minus 5x, and negative 6 times 1. So we know we got it right. X minus 6, x plus 1. On to our next question. They're nice and easy this week, aren't they? Simplify fully, that means we're going to have to factorise the top and the bottom. 2x squared minus 8. Well, 2 is a common factor, and if you're thinking about it, you could do all this in one step. We've got x squared minus 4 left over. That's a chance to do our favourite rule in maths again. Difference of 2 squared, so we've got an x plus 2, x minus 2. In the denominator, numbers that multiply to negative 10 and add to negative 3 would be negative 5 and positive 2, so it's going to factorise to x minus 5 times x plus 2. We've got a common factor there of x plus 2, that cancels out, and so I'm left with 2 outside of x minus 2, all divided by x minus 5. Answer D. Pushing on to the next question, factorise this expression. Favourite rule of maths, difference of 2 squares. You can see I included it a lot because you need to recognise it and get it right every time. Remember, the basic difference of 2 squares, a squared minus b squared equals a plus b times a minus b. But we should already have that fairly solidly. This time they've actually written it x minus 5, x plus 5. Remember, it doesn't matter the order in which I multiply those things, so that is still the same. Correct factorisation of this one, 2x squared minus 50. Take out the common factor first. Then I'm left with x squared, take 25. Oh, we remember that from last time, so it's x minus 5. Well, no, I'm going to do x plus 5, then x minus 5. Again, it doesn't actually matter though, does it, which order I write those two brackets in. 2 outside of x minus 5, x plus 5. There we have it. Next question. Factorise if possible p squared plus 100. Our favourite rule is the difference of 2 squares. That is not a difference, that is a sum. Over the real number system, that does not factorise. Specialist maths, we will look at how we can factorise that using the imaginary numbers a little bit later this term. For everyone else, does not factorise difference of 2 squares. requires a difference, not a sum. Complete the square and write in the form. So they want us to complete the square, but not to fully factorize it, just to leave it in turning point form. Remember, this is turning point form. This parabola would have a turning point at negative a b. Often we write it with a x minus h there, all squared plus k with an a in front. Doesn't matter, this would still have the turning point. It's still in turning point form, so that would be minus a, and b would be the turning point. To go ahead and write this, you need to be thinking about making a perfect square. A squared plus 2ab plus b squared, because that factorizes to a plus b squared. If there was a negative sign in front of that second term, we'd be trying to get it in the form a squared minus 2ab plus b squared to end up with a minus b all squared. So I'm going to start with this one, y equals x squared. That middle term, I want it to look like 2 times whatever was being squared first times another number. So 8x is 2 multiplied by x multiplied by, and we've still got to equal 8x, so that needs to be a 4 there. Now to complete my perfect square expansion, I need to have that last term, the b, the last factor there, b, I need to add that on squared. So I just add on 4 squared. I can't get rid of my plus 2, it was always there. But I've said that y equals this, and I'm saying this is an equivalent expression, so I've got to make sure that it maintains equality. I added on 4 squared, so I subtract 4 squared at the end. Now I know the first 3 terms are a perfect square, so that factorizes nicely. It's just going to be x plus 4 all squared. Simplifying the end bit, 2 minus 16 is minus 14. We didn't need to keep going and factorizing, we can just stop there. So x plus 4 all squared minus 14, answer A. If you were solving using the quadratic formula, what numeric value would replace the question mark? Remember, the important thing with the quadratic formula, it's not just this, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hope you're thinking about the dancing baby while you're singing the song in your head there. But there's a bit that comes before that. That is, if ax squared plus bx plus c equals 0, then x equals, and the rest of your quadratic formula there. So I have to think about this as being in the right order. This is really 3x squared minus 2x plus 6 equals 0. Now I can see that to have negative b, it's going to be negative 2, which is positive 2. So my answer is C. What is the correct solution to the following quadratic equation? Hopefully you didn't mess this up. We've even done this one a little bit earlier. When you have a quadratic, or any polynomial, you should be setting it equal to 0, factorizing and solving. So here when I factorize, I've got 2, and I'm left with x squared minus 25. Now I can finish that factorization using my favorite rule in maths, the difference of 2 squares. And you'll see that you've got 2 solutions. Obviously 2 can't equal 0, but using my null factor law, either this first bracket, x plus 5 equals 0, or x minus 5 equals 0. X equals negative 5, or x equals 5. Too many students jump in and try and do this. We've got 2x squared equals 50. This is a warning to those people. X squared equals 25, and then square root each side, x equals 5, and they only get one answer. Be careful. That is the way you first learnt solving these things when you were dealing with Pythagoras' theorem, where the answer had to be positive. When I'm solving just an equation, I need to consider that there could be negative answers. Please set it equal to 0 and factorize, and don't give away the marks. Every year we have lots of people saying, oh, I won't do that, I'll just do it the fast way, it'll be fine. And every year those people give away marks. Don't be that student in the exam. Find the nth term of a sequence 5 to the power of n. Which of these is an expression for the n plus, the nth term of a sequence is 5 to the power of n. Which of these is an expression for the n plus 2th term of the sequence? Well, if the nth term has a power of n, the term n plus 2 would be 5 to the power of n plus 2. And you go, that was easy, and then you look around and you say, that's not one of the answers. What do I have to do to get one of the answers they provided me with? I have to think about my index laws. 5 to the power of n plus 2, I could think about that as 5 to the power of n times 5 to the power of 2, using my first index law in reverse. 5 squared is 25, So I've got 25 times 5 to the power of n. That's what I'll be left with. That's why it's answer C. Very good. Getting closer. The nth term of a sequence is n cubed plus 3. Which of these is a term in the sequence? So if my sequence is n cubed plus 2, when n equals 1, I'm going to get 1 cubed plus 2 is 3. When n equals 2, I'm going to get 2 cubed, 2, 4, 8 plus 2 is 10. That was n equals 1, n equals 2. When n equals 3, I'm going to get 27 plus 2, 29, etc. You can see that we're going along pretty quickly here. Which of these is a term in the sequence? Well, we already found it, didn't we? We found that when n equals 1, did I say 1 plus 2 was 2? Clearly that's 3. And the answer is C. Look at me doing something strange there. 1 cubed is 1, plus another 2 was 3. My answer was C. Tom and Katie are discussing this sequence. Tom says the nth rule term is negative 5n plus 17. Katie says the nth rule term is 27 minus 5n. Who is correct? Well, if we just substitute in 1, let's have a look. 27 minus 5 times 1 would be 22. So that's giving me the first one correctly. And then I'm decreasing by 5 each time. If I looked at the second term, 27 minus 10 would be 17. Looks like Katie's got it sorted. Let's have a look what Tom's one does. Negative 5 times n would be negative 5 plus 17. I think Tom's messed up here. He's got a negative where he shouldn't. Negative 5n plus 17 would be negative 5 plus 17 would be 12. Looks like Katie is our winner on this occasion. Only Katie. Pushing towards the end. Question 15. These are the first 5 terms of the sequence. What describes the numbers in this sequence? We want you to be able to recognize these numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc. They are the square numbers. You need to just be comfortable that you can recognize those numbers fairly easily. Isaac is trying to work out if 323 is a term in the sequence. On the right it is working out. What conclusion should he draw? Let's check the working out. Yep. If it's a term in the sequence, it'll satisfy the formula. Adding 7 to each side, 4n equals 330. Dividing by 4, n equals 82.5. Yep, that's the correct mathematics. Hasn't made a mistake with the maths. If n equals 82.5, 82.5 can't be a term in a sequence because the terms go up by integer values. So 323 is not in the sequence. It is a value between the 82nd and 83rd term. That looks pretty good to me. Can't have the 82.5th term. 82.5 is not in the sequence. And it did answer the question. Almost there. Here are 3 terms of a sequence. Is it arithmetic or geometric? Arithmetic sequences increase by a common difference. What's the difference? 10, then 30. Oh, I'm guessing that's not arithmetic. Geometric, increase by a common factor. 5 times 3 gets me to 15. Multiplied by 3 again gets me to 45. It is a geometric sequence. Question 18. Dots have been arranged in these patterns. How many dots would there be in pattern N? Well, these 2 dots out the front, they're always the same, the leading dots, aren't they? So I'm always going to have 2 dots out the front, and then it looks like I've got a vertical column of 4, and the number of columns depends on the term number. I only have 1 column for the first term, 2 for the second, 3 for the third, 4 for the fourth, etc. So that looks like the rule for my pattern. So in pattern N, I'd have 4n plus 2. Answer A. The rule for the sequence, multiply the previous term by 2 and then subtract 3. The first term is a plus 2. Which of these is an expression for the second term? So I just need to take a plus 2, multiply that term, so term 2, is take the first term, multiply that term by 2, then subtract 3. And now we're just expanding. 2a plus 4 minus 3, 2a plus 1. Answer D. Question 20, we're almost there. U to subscript n plus 1 equals 3 times un. So to get to one term, you multiply the previous term by 3. u1 equals 5. They're asking me, I can barely read that. Let's actually zoom in a little bit there. The 8th term there. What is the 8th term? Well, if I'm multiplying by 3 each time, I could actually just multiply by 3 7 times. So it's actually going to be 5 times 3 to the power of 7. Wow, 3 to the power of 7. You may have needed a calculator for this one. I'm certainly going to need one. Let's have a look and see what it is. Well, without one handy, let's just see what we would have done. 3, 9, 27, 81, 243, 729. That's 3 to the power of 1, 2, 3, 4, 5, 6. Oh, it's only one more to go. 3 times 700 is 2100, and 329 is 87. Oh, we got there in the end anyway. So I'm multiplying 5 by 2187. It's going to be the 10,935, and we are done. They are your solutions for week 1. Make sure you get stuck into the next one. Keep up the good work, and I'll see you in the next video. Bye for now.